Hi, my name is Ellie,
Hi, my name is Erica.
and we are.
The math team.
Okay, so she's not that. Anyway, so we're finding the arc length.
And the area of the sector.
Okay.
First of all, this little yin-yang sign right here, the circle with like a squiggly line through it, that's called theta. In other words, it means the central angle maker. Next, R. If you don't know what that means, you probably should do this class. It's radius, which means it's half of the diameter. And lastly, pi, 3.14. There's a day dedicated to it. This is all the stuff you need to know, and now we're going to have Ellie show you how to change radians from degrees, because you may need that, but not right now.
Okay, you guys, so we're going to try to find the radians and degrees. This is the radians, which is 2 pi, and then we have 360, which is the degrees. To find the degrees into radians, what you have to do, you have to multiply pi over 180. Now, you guys, we're going to simplify this into 360 over 360 pi over 180. Right? And then from there, what you want to do is simplify. When you put it in the calculator, 360 pi over 180, you will get 2. Now what's all left is, so to find the radians into degrees, it's kind of the same thing except you switch it up. So you do 180 over pi, right? And then you want to take out the pi because they are both in each side.
And Ellie, before you continue, that's a multiplication sign right there, right?
Yes, this is a multiplication sign. I'm sorry, you guys. Yeah, hope you guys can see that. But anyway, so you want to do 180 times 2 because the pi is gone already. So you do 180 times 2, which is 360. And the pi is already gone because you already cross-multiplied that. And that's your degrees. So today, you guys, we are trying to find the arc length. So the first step about finding the arc length is knowing the formula. Because if you don't know the formula, how are you going to do it? Okay, so it starts by central over 180 times pi times radius equals angle times pi times r over 180. Now this is just a little shortcut from this. So then once we start trying to find the arc length, then it'll be easier. So we have our radius and angle, all right, to find, the arc length. The first thing you want to do is write your central angle. So that would be 120, right? Then you multiply that because that's your pi. Your pi equals 3.14, as you should know. Right. And then your radius. Now your radius is 11 centimeters. So then you write it right here. And then you divide it by 180. And once you put it in the calculator, you will get 2303. Now remember, you guys, you have to put your units. Because if you don't put your units, it's not right, okay? Alright. So you get centimeters.
The area of the sector. Before we do anything, we need the formula. And the formula is theta, or the central angle, times 3.14 times the radius squared over 360 degrees. This is our problem. What we need to find are all of the components of this formula. First, the central angle, which is right here, 285 degrees. We times that by pi over 3.14, as you should know. Last, we have the radius squared, not times 2, times itself, squared. The radius is 8 inches, so we get 64 instead of just 8. Over 360 degrees. And as soon as you're done doing all that, you take your handy dandy calculator or your cell phone And doing just the top half, this is what I got doing just the top half. $57,273.6. That's just the top half. Now divided by 360 degrees, you get 159.1. That's your answer. 159.1 inches squared. You can't forget your units. And if you got the answer wrong, you should probably check your calculator and make sure it's in degrees and not radians. And that is how you find the area of a sector.
So now that you understand the concept of how to find the arc length and the area of the sector, well, there's more to it. So we're trying to find today the arc length without angle. Oh no, we don't have an angle. What do we do? Well, you guys, I know what to do. Alright, so the first thing that you want to do is kind of like vice versa kind of thing. So you do 284.96, and now that you have the area of the sector, you want to find what the central angle is. The central angle, you don't know yet. 3.14 times 11 squared over 3. Now, the first thing you want to do, don't panic, calm down. You want to multiply 360 on both sides, because you always want it to balance it out. So once you do that, you get 104,385.6 equals the angle times 3.14 times 11 squared, which now you have that. You don't need this anymore.
You have simplified this, and along with your 360, because 360 go bye-bye. Anyway, so now you just want to simplify it even further. So 3.14 times 11 squared will get you to 379.94, and we're going to give an x instead of the angle, because all we're trying to do is just find that angle. And to do that, you want to divide so you can get rid of this side. So 379.94, and then you put this in the calculator. Once you put it in the calculator, central angle, which is 274.7. Now that you found your central angle, you want to use your arc length formula. So it'll be central angle times 3.14 times radius over 180. And then you just plug it in. So the central angle is 274.7 times, you know what I mean, times the radius. Now we get to radius. The radius is 11 centimeters, okay, over 180. And what did you get, you guys? Final answer, plug it in the calculator, 52.7 centimeters. Now you guys, you have to understand that, the first time I did it, I didn't really comprehend that you have to first use the area of the sector. That's the first thing, because the area of the sector is the whole circle, and you already have the answer to that. So from there, then you move on all the way to this formula, which is the arc length. And make sure that your radius is in the right place. So if you have the area of the sector, the radius has to be squared. If you have the arc length, the radius is only 1. So make sure all your calculations are correct and it all follows through. So, to check your work and you want to make sure that everything is accurate and everything is in place, since we already found the arc length, but you're not really sure if it's right or wrong, we can always flip-flop it or change it to just make sure that everything is in place. So, start by the arc length, which is 52.7, which is what you got. This is your answer, equals the central angle. Now we know the central angle is 274.7, but we're going to try to make sure and see that it's correct. So put in the formula, let me just erase this part, and the radius, which is 11 over 180. And it's the same concept. You multiply from both sides, 9,486. And then you simplify this because this is gone now. Goodbye, 180, goodbye. 3.14 times 11, right? And you get 34.54, all right? And then you want your central angle, even though we already know what it is, but we're trying to figure this out. So we divide it on both sides. Like I said, you want it to be equaled out. 9,486 divided by 34.54, and you will get your central angle, which is 274.7.
Okay, now we're finding the area of a sector without the angle. Here's our part of a circle, and all we are given is 10 meters. But then it also gives us the arc length, 23.55 meters. So here it is, 23.55 meters, which is the arc length, and then I put the formula right next to it. We label out everything that we're given, and what we're going to do is we're going to do everything backwards. So we multiply 2.55 times 180 to 23.55 times 180, and we get 4,239. And then when we move on to the top part, the theta is there over here, but I just didn't write it because I don't want to cause you guys stress, whatever. So we do 3.14 or pi times 10, and we get 31.4. 4,239 over 31.4, 4,000 to 135, and that is our central angle, 135. And moving on from that, to find the area, the last thing we'd have to do would be to input that into the area's formula. So the area's formula is the central angle, 135 times 3.14, then times radius squared, which is 10 squared, all over 360 degrees. Let me input that into my calculator. Get 117.75. And that's how you do it.
Area of a sector or arc length. If you were building this, notice how this is a circle, and this small space, in order to estimate how small of a space you'd need for them both to match up, so someone could pick this up, you'd have to find the arc length to make sure that both are the same size, and you'd have to find the area of a sector to make sure you fill in the right amount of space. So this isn't too big or too small. Another example of how arc length or area of a sector would be used in real life is making tire wheels.
Area of the sector could be portrayed in here too. Da, 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 da. Even in the trash can. See? Do, 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 do.